Section 7.1, page 366, try yourself 1. Write the claim as a mathematical sentence, state the null and alternate hypothesis, and identify which represents the claim. For number 1, a consumer analyst reports that the mean life of a certain type of automobile battery is not 74 months. And so instead of writing it, I'm just going to underline here, the mean is not 74 months. So we're going to be looking for the null hypothesis and the alternate hypothesis. And the thing about the alternate hypothesis and the null hypothesis, the null hypothesis has to have equality in it. It has to have either an equal, a greater than or equal to, or a less than or equal to. So the null hypothesis has to have equality. Always. And the alternate hypothesis is actually going to tell you what tail test it is. So in this case, it's not 74 months. So that's not equal to. So the mean is going to be the mu, not equal to, and then it's going to be 74. So that's going to be an alternate hypothesis because it's not equal. So it's going to be mu is not equal to 74 months, and that is going to be our claim because it also asks you to identify the claim. I usually just put a CL in parentheses or a C in parentheses so I know which one is the claim. And so that leaves our null hypothesis to be mu and 74. That's always going to be the same for the alternate and the null. And so here it's going to have to be the opposite of not equal, which is going to be equal to. For number 2, a television manufacturer publishes that the variance of the life of a certain type of television is less than or equal to 3.5. So here we have variance, which is going to be sigma squared for both of them, is less than or equal to 3.5. So variance is sigma squared, and less than or equal to, so less than or equal to, less than is like your left hand, or equal to 3.5. And so we've got our null hypothesis and our alternate hypothesis, H sub 0 for null, H sub A for alternate. And so since this has an equal to bar, then it's going to be the null hypothesis, the less than or equal to. And that's going to be 3.5. So the opposite of that is greater than 3.5. All the numbers that aren't less than or equal to 3.5 must be greater than 3.5. And our claim is what they state here. So the claim is the null hypothesis in this case. For part 3, a radio station publicizes that its proportion of the local listening audience is greater than 39%. So here's proportion, so that's going to be our P. Is greater than, it's just the greater than symbol, and 39% we're going to use 0.39. Use your decimals for the proportions. And so is this going to be the null or the alternate hypothesis? Well, since it doesn't have any equality, it's just greater than, it's going to be your alternate hypothesis. So that's going to be P is greater than 0.39, and that's also going to be your claim. And so that leaves the null hypothesis to be P 0.39, but in between here it's going to be the opposite of greater than, which is the less than or equal to. 1, page 371, try it yourself 3. For each claim, determine whether the hypothesis is left, right, or two-tailed test, and sketch, I'm going to ask you to sketch the critical regions. And so in this case, the way to find whether it's a left tail, right tail, two-tailed test is to look at the alternate hypothesis. So to determine this is we look at the H sub A. And so first we need to determine our null and alternate hypothesis. So in this case, consumer analyst reports that the mean life of a certain type of automobile battery is 74 months. And so that's our claim. And that's also going to be our null hypothesis here. It's the mu for mean, and it is 74 months. And that's going to be our claim. It's not going to really matter right here. So that means that the alternate hypothesis is going to be the opposite of equal to, which is going to be not equal to. So it's going to be not equal to 74 months. And so this tells us that our critical region is going to be not equal to, which is a two-tailed test. So for this one, our answer is going to be a two-tailed test. And we're going to draw our critical regions. So just draw a normal standard curve, best you can there. Zeros in the middle. So if it's two-tailed test, you're going to end up with a positive z sub 0 critical value, and you're going to end up with a negative z sub 0 critical value. Now let's take a look at number 2. A radio station publicizes that its proportion of the local listening audience is greater than 39%. So greater than 39%, that's going to be our claim. And so let's see what our null and alternate hypothesis are going to be. It's going to be P for proportion. This is going to be P for proportion. We're going to use 0.39 for the probability here. And we've got our alternate here. So it's going to be 0.39 for our proportion. So is it going to be the alternate or the null? Here, greater than is not an equal to, so that's going to be the alternate hypothesis. So our null is going to be less than or equal to. This is our claim, but what really matters here for these is determining what kind of test it is. So since it's greater than, it's in the alternate hypothesis. That tells you that it's going to be a greater than, so it's going to be on the right-hand side or a right-tailed test. So for number 2, it's a right-tailed test. And that's just going to be a positive critical value on the right-hand side. Section 7.1, page 373, try it yourself, number 4. You perform a hypothesis test for the following claim. How should you interpret your decision if you reject a null hypothesis or if you fail to reject a null hypothesis? So first let's take a look at our alternate and our null and how the outcome would look. So the H sub A, the alternate hypothesis here, is that a radio station publicizes that its proportion of the local listening audience is greater than 39%. So its proportion, so that's going to be P, is greater than 39%, 0.39. That's the claim. Okay, so the null hypothesis, the H sub 0 would be P is less than or equal to 0.39. And that's not really all that important, but what's important is that you get the idea of how it's going to look when you're done with your problem. So let's take a look. We'll call it part A here. If you reject the null hypothesis. So if you reject the null hypothesis, you're rejecting this right here. So you're accepting the claim. So if you're accepting the claim, you're accepting the whole idea of what they're saying here. So there is enough evidence to support the radio station's claim that its proportion of local listening audience is greater than 39%. Since you rejected the null hypothesis, then you accepted the alternate hypothesis would also happen to be the claim. And now let's take a look at part B. For part B, we're going to call it part B, if you fail to reject the null hypothesis. So now we're going to fail to reject the null hypothesis. That means we're going to accept the null hypothesis, which is not the claim. And so what would our outcome be then? What would we state? How would we interpret it? So in this case, we would say that there is not enough evidence to support the radio station's claim that its proportion of the local listening audience is greater than 39%.